In our next section, which involves trigonometric graphs, you will see in your notes, since this is a Red College section, you will know that the graphs that we're interested in is sine, cosine, and tangent. Now, traditionally, your instructor will rarely ask you to sketch these by hand. I certainly wouldn't ask you to do that by hand, but I think as a little exercise, we should see if we could figure out what would be the key points in graphing something like this. Now, most of you have your very powerful HP calculators or your Casios, etc. You would simply type that into your graphing domain function and it spits it out. But suppose the instructor was a little cheeky and said, well, can you draw it by hand and show me how you would get the values? Well, you would have to figure out, first of all, you would set up your y and x axis, and then the thing that you would have to ask yourself is, what would be the period? Where would it turn? And what would be the amplitude? So there's a couple of little things you can figure out mathematically, and one of these, of course, would be the amplitude, A, would be 3. And that's the multiplier. But how do you know the period? Traditionally, if it was a sine graph, you know that for sine x, what would be the period? The period is 2 pi. And that is because within the rotation of 2 pi radians, the graph completes a complete cycle. But in this case, how long would it take? And we also know that this particular one would be 3 units high. What might be those points, and how do you know? Well, think about it. When x is 90 degrees, this would be 90 degrees that translates to what we would call 180, completing its first turn. And then over here, this officially would be 180, but the old 360. So what you're noticing is that it turns at half the time. So by looking at this particular graph, you know also that this is 3 units high. And the turning rate is at half of a traditional sine function. So you can do it without a calculator. Of course, I don't recommend it, because you would get something that is shifted. You might get something that is 2x plus 5 over 2 pi. And that becomes quite difficult. And you can also have another shift where it's another plus 6 or something like that. So this is one way you can do it. And of course, it's a nice little exercise to understand how you're using it in your calculator.
We need